Welcome all of you. Today I will discuss about fluid static. Myself, Sri Kausik Bera. I am doing my PhD from NIT Silchar uh, in the geotechnical engineering. I am a assistant professor of uh, civil engineering department at Holdia Institute of Technology. So this is going to module 2. We will discuss about this, and my topic is fluid static. Today's contents are pressure at a point, basic equation for a pressure field, absolute pressure, gauge pressure, pressure measurement by manometers, general, inclined, inverted, micromanometers. Fluid static. So we will have to know what is fluid static. Basically, fluid static, it is the branch of fluid mechanics that deals with the behavior response of fluid when they are at rest. What is pressure? So pressure, it is a normal force exerted by per unit area. It is denoted by P, and given P is equal to force by area. That means the F by A. So what are the units in SI, CGS, BG? SI units is Newton per meter square called Pascal. BG units in pound per foot square called PSI. CGS unit is dyne per centimeter square. And another 1 bar equals to 10 to the power 5 Newton per meter square. You can say that the 10 to the power 5 pascals. So pressures versus water depth or height. So there is a relation between pressure versus depth of height of water. So consider this is a cylindrical tube and the height is h. So at the top of height or top of the column or cylindrical uh, about the pressure fluid is 0 and the bottom is maximum. So that means if the depth is increased, the pressure will increase. So there is some relation. So how we build the relation? So pressure at a base of a strip is df by dA. So if we consider h is the height or the depth of a strip of a fluid, gamma is a specific weight, dA is a cross-sectional area of a strip, dV is a volume of a strip, and dW weight of a strip. So now if we consider at a base of a strip pressure, pressure means force by area. So there is a force df by dA. So what will be the base force? So base force will be the weight of the fluid. So weight of the fluid is dw by dA. We consider a small strip. This is the going to in this slides, and dw, that means the weight, we can write the gamma into dv, and so we can write dv as a dA into h. So finally it become P equals to pressure equals to gamma into dA into h by dA. So we can say P equals to, that means the pressure equals to gamma into h. dA will be cancelled. So remaining part is P equals to gamma into h. That means the with respect to specific weight into height. So when the height is increased, that means the pressure will increase. At the top, height is 0, the pressure will be the 0. So bottom, the height is maximum, so the pressure will be the maximum. This is the relation between the pressure versus water depth. So now this is the in your slides you can see that the how it is become a triangle at the pressure bottom pressure distribution diagram. So bottom is maximum and the top is 0. So h is 0, that means the pressure is 0. H is h, that become the P equals to gamma into h. So that means the P proportional to the h. So there is a Pascal's law in pressure. So Pascal's law says that the pressure at any point in fluid is same in all direction when the fluid is at rest. That means in anywhere that at any point the pressure will be in a fluid, in pressure will be same in all directions. So in these slides you can see that the this is a filled with a fluid, and this is some triangle, smaller triangle. We consider if the wedge we consider in this wave shape, wave shape, the direction x direction, y direction, and z direction, there will be same pressure in at same point. At any point there will be same pressure. This is the diagram described. And finally, if we consider the fx means x directions, x direction pressure, x direction force equals to 0. As we know, the summation of fy equals to 0 and summation of fz equals to 0. So fx, the including here this diagram, the all direction x sides, at the x direction, all the pressure will be, all the force will be 0. So this is in your slides is showing, going to show that the all the force in x direction is 0, all the force in y direction is 0, all the force in z direction is 0. Similarly, it's become px, py, pz equals to p. That means the same pressure. So applications of Pascal's law. Application of Pascal's law. There is lots of application in Pascal's law. Basically in hydraulic systems. So this is in your direction. The in your hydraulic jack, in your garage, you can see that the car pressure in the left hand side pressure and right hand side pressure is equal. So this is the application of a Pascal's law. Now absolute and gauge pressure. So this is a basic thing of a atmospheric pressure, gauge pressure, negative pressure, and absolute pressure. So we have to, in reference, we have to think about there is some reference point. Okay. After that, in your diagram, this is the absolute zero, bottom is absolute zero, and the right, y direction is pressure. So here we can say there is atmospheric pressure exerted by the atmosphere. This is called atmospheric pressure. There is no vacuum pressure in this world in natural. Okay. So all these are, everything is an atmospheric pressure. It may be low, it may be high, but in this under of atmospheric pressure. So we can say that the pressure exerted by the atmosphere, this is called atmospheric pressure. What is gauge pressure? In this diagram, atmospheric pressure and upper more than the atmospheric pressure, this will be the gauge pressure. So pressure more than the atmospheric pressure, we can say that the gauge pressure. And vacuum or negative pressure, what we can say the negative pressure. So below the atmospheric pressure, less than the atmospheric pressure, which is called, this is called vacuum or negative gauge pressure. This is the in your diagram, this is the in your diagram. So look, this is in your diagram, this is the gauge or negative pressure. And absolute pressure, so absolute pressure is defined by two ways. So if we can say absolute pressure is P atmospheric plus gauge pressure, we can say atmospheric pressure, or we can say P atmospheric minus P vacuum. This can be say the absolute pressure. There is no absolute pressure in existing in real life. This is the atmospheric pressure. We can say in your slide, we can say that the atmospheric pressure, it is defined as the weight of air per unit surface area of Earth. It decreases with increase in elevation. And standard atmospheric pressure, we know 10 point standard atmospheric pressure. We know that the uh, uh, okay, there is some 10.3. Okay, so how can we measure the atmospheric pressure here? So now we will measure the atmospheric pressure with liquid barometer. So how this in the slides? So there is liquid barometer in bottom side. There is air pressure, and after this is the vacuum and this tube, glass tube, and this is the liquid mercury we generally in use, and this is the liquid mercury, and this is the weight of liquid. This is the downward side, and air pressure is upward side, and there is some vacuum, and this is a glass tube. Okay, three forces acting on the fluid. This is the P atmospheric force on atmospheric pressure, weight of liquid, uh, force of vapor pressure, and A of area construction. This is not a pressure, this is a area means area of this cross sectional of the tube. Okay, so it is a consist of a transparent tube which is open for one end only. The tube is filled with the liquid and is inserted in a jar also containing same liquid. The liquid initially drops in tube due to the gravity but stabilize at a certain level under the action of atmospheric pressure. The atmospheric pressure is then measured as height of the liquid at which is stabilized. So this is the gauge pressure, vacuum pressure, absolute pressure. We know that, and measurement of pressure is also device we used is piezometer, manometer, mechanical pressure transducer, and electrical pressure transducer. Piezometer. So it is used. This is in a diagram. This is a small tube connected with a dial, some dial reading, and with a glass tube with a connected with a pipe. So it is generally used to measure pressure in pipe or vessel. In its simplest form, it consists of a transparent tube open from another ends. The diameter of the tube should greater than half inch to avoid capillarity action. Piezometers may be connected to a slides or bottom of pipe to avoid eddies that are produced on the top of the region. And it has some limitations. It is must be only used for liquids. It should not be used for high pressure. It cannot be pressure vacuum pressures. So manometer. So this is a simple manometer. In this diagram, this is a simple manometer. We can say in this manometer we can measure the pressure difference of the fluid and also the pressure at a point A. So it consists a U shape and tube, part of which filled with a manometric fluid. It may be the manometric fluid is oil. It may be the mercury, generally used mercury. One end of the tube is connected with the pipe whose pressure is required to be determined. Due to the pressure of level, manometric fluid rises on one side while it's fall on other side. The difference level is measured to be estimated the pressure. So here this in this diagram, this is the height is Z and this is the difference is y to manometric difference. This is a side and other end is open, and this is a ym. This is the specific weight of a manometric fluid, and yf, this is a specific weight of the fluid, and y is manometric reading. So manometer fluids are in generally mercury, what I already told, oils, salt solution, and properties of a manometric fluid. There is some requirement of properties. Otherwise, anything cannot be put in the manometric fluids. Manometric fluid should not be soluble, intermixable with the fluid flowing in pipe whose pressure is required to be determined. That means there is no same fluid in manometric fluid and the normal fluid. It not be same, and lighter fluid should be used if more precision is required. So how we measure the pressure measurement in manometer? So this is a simplest form. We can say that in this diagram you can see that this is a in left hand side, this is a pressure at A, and this is atmospheric pressure, and other is this is which is open and which is P is downward. So if we cross check in like this section XX, we can say that. So in generally we say that the left hand side pressure and right hand side pressure will be equal. So what are the left hand side pressure? So we can say PA, and the we can say that the PA into gamma F into Z distance, and the right hand side pressure is P atmospheric pressure plus y into gamma m. Gamma m is a manometric fluid specific weight. If if the forces on left hand side and right hand side be equal, automatically we can find out the any pressure of a fluid. So this is the in your slide we can we see that this is the differential manometer. This is one end is A and other end is B. So there is two fluid A and fluid B. That means the properties is changed, and the manometric fluid is also in the two between. This is not the manometric, this is another fluid which is not the same or A fluid or B fluid properties. So how can we measure? So first case, when the two vessels pipe are at the same level, if the same level, so we can say that the left hand side we cross check these things, and left hand side pipe and right hand side pipe, all the pressure is same. So we can find out Pa minus Pb equals to gamma B into Zb plus gamma m into Y minus gamma into Za. Similarly, this is the parametric difference. Second case, when the two vessels and pipes are difference level, that means the A is in higher side, B is in lower side. So same thing, we will follow the at a say cross section in this level, at a left hand side pressure and right hand side pressure, if we equal, so it become Pa minus Pb equals to gamma B Zb plus gamma m Y and minus gamma A Za. So this is the thing. And differential, this is the inverted manometer in third case. So inverted manometer, automatically what happened, that pressure will be downward. So in this case, it's the same thing, x direction and y direction, left hand side and right hand side pressure will be the same, but in the negative direction, downward. This is we change the negative, so we become Pa minus Pb equals to gamma minus gamma B Zb minus gamma m Y and plus gamma uh, gamma into gamma B into Zb, or you can say gamma A into Za. Okay. So this is the thing. Advantage and limitations of manometer. So advantage is easy to fabricate, less expensive, good accuracy, high sensitivity required, little maintenance, not affected by the vibration, especially suitable for low pressure and low difference, easy to change, and sensitivity by changing manometric fluid. Limitations are usually bulky and large in size, being fragile, get broken easily. Reading of manometer is generally affected by the temperature and altitude, gravity. Capillary action is created due to the surface action. Meniscus has to be measured accurately for better accuracy. And another is mechanical pressure transducer. Transducer is a device is in, so transducer is generally used in our industry purpose. Mechanical transducer we used. It is a device which is transfer the energy from system to other. Mechanical pressure transducer converted pressure system to a displacement in mechanical measuring. This is the burden gauge. We can say if the pressure is automatically, it will show in your open pressure dial. Generally, we use in this burden gauge in everywhere nowadays. This is the elevation correction for a PA, where PG and the gamma Z elevation correction for different elevation. There will be different pressure. So electrical pressure transducer, it converted displacement of mechanical measuring system to an electrical signal. It gives a continuous record of pressure. When the converted to a strip chart or recorder, data can be displayed using computer data acquisition system. Thanking you.